Refrigeration uses the phase change of a liquid to a gas to absorb heat from the surrounding environment. But what liquid should it use? Water's intermolecular attraction is strong, and therefore its boiling point is very high. Water cannot even start dissipating heat until it reaches 212 degrees. So refrigerants were developed that take advantage of liquids that can change phase or boil at a much lower temperature and that won't freeze at the temperatures used to freeze food. The ideal refrigerant will have a certain set of characteristics. First, its intermolecular attraction must be weak enough that it takes little heat to force molecules apart at normal operating temperature and pressure. Second, its freezing point must be well below the lowest temperature that we want to achieve. And it must be hardy enough to undergo the phase change repeatedly and indefinitely. The first refrigerant that Frigidaire used was sulfur dioxide. Then Frigidaire engineers developed a new refrigerant, R12, also known as Freon. It was chlorine-based and contained mineral oil to provide lubrication for the compressor. R12 became the industry standard for years until the environmental effects were discovered. Today, R134A is the industry standard refrigerant for refrigerators and freezers. It contains no chlorine and uses ester oil to lubricate the compressor. So we have a liquid that can boil, absorbing heat at temperatures that are below the temperature at which we want to store food. But after boiling, the liquid, in a gaseous state, can no longer provide any cooling. How then do we convert it back to a liquid state so that it can boil again?